Hello everyone, I am Arun and I will be guiding you in this tutorial about how to use Spacept's tree detection and hide from shadow processing block on up42 platform. Here we will be discussing about creating an up42 workflow using this processing block. The block detects and estimates the height of the trees from RGB images in GeoTIFF format. You can visit the blog's page in up42 Marketplace for all the details regarding this blog. Now let's dive into the console for next steps. Let's start by creating a project. Once that is done, we will create a workflow. We will name this workflow as tree height demo. The workflows in up42 require a data block and followed by processing blocks. We will now add our data block. Currently, we are choosing Pleiades display download as our data block. We can also choose the streaming block, but we will not be able to download the original image once the processing is done. We will now add this block. Since the original image is not in GeoTIFF format, we will need to convert it first to the GeoTIFF format. For that, we will use a block provided by up42 for the same. For large area of interest, if we want to optimally detect the trees, we will need to first convert the source image into smaller tiles. This is done by up42's raster tiling block. We will now add this block to our workflow. Finally, we can add our tree height detection block from Spacept. As of making this video, there are two versions, and for this video we will select the latest version, which is 2.0.2. Now our workflow is complete. We can now save this workflow and configure our job. This is the up42 page to configure a job. It contains a map to mark the area of interest, and on the left side it contains a panel to edit the parameters for the job. Now we will consider a scenario where we want to analyze an area near a rain line in France. For that, we will now search for our area where we want to analyze. We can switch to satellite imagery for a better perspective. As we zoom in, we can see the rail line that we are interested in, followed by which we can now start marking the area of interest. After marking the area of interest, we can now set the job parameters. We will set the job type as test query. It will confirm if we have an image over the area of interest during the given time period. We can also set other parameters such as cloud coverage, In our case, we will set the maximum cloud coverage to 20%. We can also set other parameters, but we will leave them as such for now. The panel also estimates credits that will be consumed if we run it as a real job. We will test our job now. The test job will be successful if we set our parameters correctly and we have enough images in our area of interest with those parameters. Now we will run it as a real job. It's going to take some time to complete, so I will pause the video now and we will resume it after some time. After triggering a job, we can always come back to the jobs panel to check its status. Here we can see that our latest job is completed. We will now open the job to view the results. Since we chose a download data block, we will be able to download the original input image along with our final result. We will now download our GeoTIFF image along with our final processing output. The output of our job will have several files. The folder contains the output of individual tiles. Each tile contains the probability map for tree and shadow, and also several output files which will have the height information on all these tiles. The all tree heights file contains height information from all the regions combined. The data.json file contains all the metadata regarding the job. The entire process shown till now can also be done using the up42 Python SDK. The job executed in Python SDK is shown in another notebook prepared by Thais from up42. I'll share the link to that notebook here. Let's see how we can visualize the data in Jupyter Notebook. We are using Kepler GL library for visualization. The installation steps can be found from the official website. To start the visualization, we will first import the required libraries. Next, we will import the all tree heights GeoJSON file. Then we will initialize a Kepler GL map and add the data to it. We will now load a previously prepared configuration file. I will share the preparation script with this notebook. Finally, we can load the map with the configuration. As you can see, the trees are now displayed with their height and a color based on their height. The tutorial is now complete. Feel free to reach out to Spacept or up42 if you have any queries regarding this block. Thank you.